So there are two ways to this. We can use the vectors where we look at the product being 12 and then the sum being negative 7. So which two numbers do we multiply to give us 12? But when we add those numbers, we must get negative 7. So if I use the vector method, whereby I have my two brackets equal to 0, it's going to be x minus 4 and then x minus 3. Because negative 3 and negative 4 will give me positive 12. When I add negative 3 and negative 4, I get a negative 7. So with this first bracket, I will equate it to 0 and say either x minus 4 is 0 or x minus 3 is equal to 0. So which means if I solve for x, my x is going to be 4 or x is going to be a positive 3 that side. And then I'll be done with that. Alternatively, someone can also use the quadratic formula whereby your a is 1, your b is negative 7, and then your c is 12. And then all you have to do is substitute. Plus minus, you said it's a b squared minus 4ac. Everything is divided by 2a. And then when you substitute these values into the formula, you should be able to get the same answers. Alright, then 1.1.2, they're telling us that if we have x into 3x plus 5 is equal to 1. Now, whenever they tell you that you must give your answer correct to decimal places, in most cases, they need us to use the quadratic formula. Okay, so what I'm going to do, I'll start by opening up this and create a standard form of this equation. So that's going to be 3x squared, and then x and 5 is going to give me 5x is equal to 1. Then I can transpose this one to the left. So that is 3x squared plus 5x minus 1 is equal to 0. Okay. Then from there, I can tell that my a is a 3, my b is a 5, and our c is negative 1. And then I'll just substitute this into the quadratic formula. We said negative b plus minus square root of b squared minus 4ac. Everything is divided by 2a. So my b is a 5, so that's going to be negative 5 plus minus the square root of 5 squared minus 4. My a is a 3 and my c is a negative 1. All this is divided by 2 times 5. Okay, I may choose to do just a substitution and get my answers straight away, or I may try to simplify it further so that I have a negative 5 space plus minus. I know that my 5 squared is 25. This is 4 times 3 is 12 times that, which is going to be like 25 plus 12 over 10. Okay, when I put that into my calculator, that's negative 5. I'll start with a plus sign. Square root of 25 plus 12, dividing it by 10. Come on. I'm getting 0.1 something. That is just a moment. So it's negative 5 plus square root of, that is 5 squared, sorry. Our a is a 3, not a 5. Sorry about that. Our a is a 3. So which means the first x is going to be 0.18. and then I'll just replace the plus with a minus sign, this minus sign here, and then my x is going to give me a negative 1,85 from round it off to decimal places. So those will be our two answers, the 0,18 and then the negative 1,85. Then 1.3, being told that if we have x squared is less than negative 2x plus 15. So since the highest degree is a 2, or the degree of the equation is a 2, we can create a standard form so that everything is on one side of the equal signs and then the 0 is left on the other. So I'm going to move this 2x that side and then the 15 that side also. So that's x squared plus 2x minus 15 is less than 0. Okay, so we're seeing a quadratic again. We can use the quadratic formula or we can use the vectors. So if I use the vectors, the two numbers I multiply to give me negative 15, and then when I plus them, I will get a positive 2, only see negative 3 and positive 5. Multiply this, I get negative 15. I add those two, I get a 2. Then that's going to be x minus 3, and then it's going to be x plus 5 is less than 0. And so from this, if there were no inequality symbol, and I assume there was just equal signs, I'll get solutions which I'm going to call my critical values as positive 3 and negative 5. Okay, but since it's an inequality and we're having a less than symbol, then this is going to be represented as the smaller number being less than the x and then being less than the bigger number or bigger value. So which means my final solution is going to be negative 5 is less x and then is less positive 3. I would prefer presenting it this way, though there are other ways of doing it. Some people can draw the graphs and so on. And then 1.1.4, we have the root of 2 into 1 minus x is equal to x minus 1. So in normal cases for such questions, we advise learners to leave the root sign on one side and everything must be on the other. So this has already been done for us. So the only thing I'm going to do, I'm going to introduce a bracket by the right hand side. Okay. Now for me to get rid of this root sign, you know that we have to square both sides. Square that, then I can get square that and put another bracket. Okay, so this 2 is going to kill the root sign so that I'm just left with 2 into 1 minus x. When I open this up, I'm going to have 2 minus 2x is equal to, when I open this, we can FOIL it, x minus 1 and then x minus 1. That's going to give me x squared minus 2x plus a 1. Then I'll create a standard solution. I can move everything to that side. There's no harm in that. Yeah. So that's going to be x squared minus 2x. That's going to be plus 2x. We have a plus 1. When the 2 goes that side, minus 2 is equal to 0. Then this is going to cancel that. And then plus 1 minus 2 is going to give me minus 1 is equal to 0. So this is a difference of 2 squares, whereby x minus 1 and then that's x minus plus 1 is equal to 0. That is if I factorize using the difference of 2 squares. And then when I solve this bracket, either x minus 1 is a 0 or x plus 1 becomes a 0. So I can see that this one is going to give me x to be positive 1, or my x is going to be negative 1. Alright, now whenever we have a square root kind of question, we always advise to go back to the question, to the original expression, and test which of the values will satisfy the expression, and then we choose. So in this case, if I use 1, that's going to be like the square root, let's say on the left hand side, it's 2 into 1 minus 1. What am I getting here? I'm getting the 0. On the right hand side, I'm having x as a 1, so that's going to be 1 minus 1, which is also 0. So this one works, or that one satisfies the equation. Let's try the negative one. On the left hand side, we have the square root of 2 into 1 minus 1. Okay, I know that 1 minus 1, that would be 2 times 2 is equal to square root of 4 is 2. And then on the right hand side, I'm going to have negative 1 minus 1, which gives me negative 2. So this second one does not give me the solution. So I can say this one is not applicable. So I'll choose to go with x is equal to 1. So therefore, x must be 1. Guys, that's 1.1.4. Move on. Then 1.2. We need to solve for x and y simultaneously. So in this case, we always have a linear equation and then a quadratic one. Okay, so we have 3 to the x plus 27. So 3 to the x plus y is equal to 27. And then x squared plus y squared. So I'm going to say 3x plus y is equal to 27. I'm going to call this equation number 1. And then I'll call this my equation number 2. Okay, so I need to create a linear equation between these two. And the easiest one is going to be this first one. So since it's in the form of an exponential, it means I can even create a 27 as an exponential. So 27 will be the same as 3 cubed. And the bases are the same, which means the exponents will also be the same. So I'm going to say x plus y should be 3. Then I can make y the subject and say y is going to be 3 minus x. You can call this my equation 3 or equation star. So I need to substitute equation 3 into equation number 2. Where there is y, I'm going to replace all of that. So with my substitution, it's going to be x squared plus, so we are replacing y with 3 minus x. I square that is equal to 17. So that is going to be x squared plus, when I FOIL that, remember it's 3 minus x times 3 minus x. So that's going to be a 9 minus 6x plus x squared. I can move the 17, that's okay, is equal to 0. Then when I group and collect my like terms, I'm going to have 2x squared. I know that plus 9 minus 17 is negative 8. Okay, so I have minus 6x. Then I say this is negative 8 is equal to 0. Can choose to divide through by 2. Okay, so that I have my x squared minus 3x minus 4 is equal to 0. And then I can use my factors, so I can use the quadratic formula either way. So I'll say this is x and x, numbers that I'm looking at to give me negative 4. When I add them, I get negative 3. It will be negative 4 and a positive 1. Okay. So which means my x is going to be negative 1 or x is going to be positive 4 when I equate these brackets to 0. Remember the dot product. X plus 1 is a 0 or x minus 4 is a 0 for us to get the solutions. So these are my x values. Then I need to substitute or replace those x values into my equation number 3 to get the y. So which means my first y is going to be 3 minus 1, which gives me a 4. And then if I use x as a 4, that's going to be 3 minus 4, which is negative 1. So at this point, y is a 4, or at this point, y is also negative 1. So I've solved that, and that's how I'll get all the 6 marks. Alright, then question 1.3. They're telling us without the use of a calculator, they want us to get the value of this. Yup, this is something else. Okay, we're having 1 over the root of 1 plus root of 2. And then 1 over the root of 2 plus root of 3, and so on and so forth. So my approach to this makes a bit tricky, but you don't want us to calculate, which means there's a quicker opening. If I try to rationalize this, what am I going to end up with? Let me rationalize just the first one. And we know that when you're rationalizing, we multiply the numerator and denominator. Okay, so I have root 1 plus root 2. So when I'm rationalizing, I'll say root 1 minus root of 2, and then root 1 minus root of 2. I open the top part. I'm going to end up with just the root 1 minus root 2, but I know that root 1 is the same as the 1, okay? Okay, over this is a difference of 2 squares, which means I'm going to have root 1 and root 1, which is a 1, minus root 2 and root 2 is going to give me a 2. So it's a root 1 minus a root 2 over negative 1. And I simplify that, I'm going to have a negative 1 plus a root 2. Okay, so this is my first term here. If this is progression, say negative 1 plus root 2. If I try the second one, I'm going to have root 2 plus root 3. And that is root 2 minus root 3 over root 2 minus root 3. I'll open that up. So root 2 minus root 3 over, this is still a difference of 2 squares. So root 2 and root 2 is a 2 minus root 2 and root 3 is a 3. So I'm still getting negative root 2 plus root 3. So there is something I'm seeing. Something that I'm seeing. That if I am to replace this and that according to the progression, I'm always going to get, let's say my third term is going to be negative root 3 plus a root 4. And then I'll have negative root 4 plus a root 5. Which means my last term, if I'm to do the same, is going to be negative root 99 plus the root of 100. I don't know whether you guys where I'm heading to. So if I'm to replace everything, it's going to be negative 1 plus root 2. But then I'm adding my second term, which is negative root 2 plus root 3, plus the negative root 3 plus root 4, and so on and so forth, up until I get to negative root 99 plus root 100. Okay? What I notice is that this is going to cancel that. The 3's are going to cancel. The 4's are going to cancel. Up to this point of negative 99, everything is just going to cancel. So I'll only be left with negative 1 and then the last expression, which is square root of 100, which I know is a 10. So negative 1 plus 10 gives me a 9. So that is how I approached this question. Okay? If you have a better way, a quicker way, please leave it in the comments. Then that is question 1. Move on to question number 2. Question number 2, they are telling us, given the geometric series, okay, we have 1 over 15, sorry, 1 over 5 plus 1 over 15 plus 1 over 45 and so on. The question is this a convergent geometric series? You must justify the answer with the necessary calculation. And so one thing we know is that the condition for a progression or a series to be convergent, there is -1 and +1. So this is the condition that our common ratio must be between these two values, between -1 and +1. So let's try to get the common ratio where we know we get T2 divided by T1, or someone can still use T3 divided by T2. There's no problem. So that's gonna be 1/15 and dividing it by 1/5. Can just put this in the calculator just to be sure. But I'm getting 1/3 as my common ratio. So when I look at 1/3, 1/3 lies between this interval. It's bigger than -1, but 1/3 is smaller than 1. So the answer is going to be yes. It's a convergent geometric series because -1 is less 1/3 and is less 1. There we go. Then 2.1.2. They want us to get the sum to infinity. We know that sum to infinity is given as a over 1 minus r. Our first term was 1/5, if I'm not mistaken. Yes, 1/5. Okay, just substitute. So 1/5 over 1 minus our common ratio, we got it as 1/3. So that's going to be 1/5 over 1 minus 1/3. That's going to be 2/3. You simplify this, you can use your calculator again. I'm going to just switch that up. So that is 3/10. Remember from your earlier grades, said when you're dividing fractions, you must use the reciprocal and the multiplicative inverse and switch the sign to multiplication. That's what I did. So it's 3/10, or someone can give it as 0.3. Then 2.2, they're telling us we have an arithmetic and the geometric are combined. And this is given as x 1/3, 2x 1/9, 3x, and so on. And they want us to write the next two terms. So when you look at the x's, it's like you're adding an x. So 1x plus 1x, 2x, and then 2x plus x is 3x. So which means we must add x to give us 4x. When you look at the geometric progression for the sequence, it's 1/3. That's our first term. Our second term is 1/9. Then that is 1/27. So the next one must be 1/81. Okay. Seems like I'm multiplying by 1/3. Alright. Then 2.2.2. You want the general term for the odd terms. So we know that odd numbers are 1, 3, 5, and so on. Yeah, those are the odd numbers, which means we want the general term of the arithmetic. We know that Tn is given as a plus n minus 1 into d. So our first term is x. This is n minus 1. Our common difference is also x. Then when you open that and simplify, it's going to be x plus, that is xn minus x. So this cancels that, which means my Tn is going to be the same as xn or nx. Check out. Then 2.2.3. Calculate P26. The term in the 26th position. The term in the 26th position. Okay, so if I'm to look at P26, Now let me just write it out. 2, 3, 4, 5, 10, 11, 12, 13, 14, 15, 18, 19, 20, 21, 22, 23, 24, 25, and then 26. So if the odd numbers are being represented by the arithmetic, which means P26 is going to be represented by the even, okay? Which even is the geometric. So what I need to do is I need to find the general term of the arithmetic, and then I'll find not P26, but it's going to be my 13th term. Someone is wondering how. So this is 23, 24, 25, and then 26. 14, 15, 16, 17, 18. Okay, so what I'm saying is that now with the geometric, which position am I going to focus on? Because I cannot focus on 26 since 26 is the general. So I'll be looking at number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So I'll be looking at T13 of the geometric. Okay. So we know that with the geometric it's A, R, minus 1. Our A was 1 over 3. We said our common ratio is also 1 over 3 to the exponent of n minus 1. Now since I'm looking for T13, it's going to be 1 over 3 times 1 over 3 to the exponent of 13 minus 1. You can just put this into the machine. So the calculator. This is 1 over 3. Oops, okay. Say to the exponent of 13 minus 1. I'm getting a very small number. Okay. That's 1 over 1594 3 to 3. Okay, so you can leave it as a decimal, which is 0, 0. Yes, it's a lot here. So that is how I would have done that. Or alternatively, by looking at the way the progression is moving, someone can quickly sense and know that no, it's just 1 over 3 to the exponent of, and then you can put the 13 there. You still get to the same answer. Alright, then 2.2.4. They are telling us that we have the sigma. And remember what we said, sigma represents summation from n1 to 21 of the same progression that is having both will be equal to 33.5 from the first one to the 21st, the one the value is. Now, if the total number of terms are 21, I'll just slightly go back. Okay. So if we have 21 terms, this is where we're ending. These ones are out. Question is, how many arithmetic? So for AP, now call it arithmetic progression. How many terms do I have? 1, 2, 3, 4, 7, 8, 9, and 10. So I'm going to have 10 for arithmetic, which means the geometric progression or series is going to have 11 terms. Is that even true? Let me just recount, guys. I don't want to make a mess. Okay? So arithmetic, we said, is the first one. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So arithmetic is 11. And then geometric will be 10. And count it the other way around. Alright, so we know that the sum of an arithmetic is given as I'm not going to look at the generals like the formula for the sum. I can look at that summarized one that talks about n over 2 into a plus l. I don't know if I find this big because I have my first term and I also have my last term. Okay. Then I'm going to add the geometric one. You know that the geometric one is given as a into 1 minus r to the exponent of a over 1 minus r. So this is the combined. So for my arithmetic, we said we have 11 terms, so that's 11 over 2 into my first term was x. Okay. And then since 21 is gonna be my last term for the arithmetic, this is gonna be term number what? We say 11. Okay, which is 11x. Then plus, when I look at the first term of the geometric, we have the 3, so 1 over 3 into 1 minus 1 over 3 to the exponent of 10 over 1 minus 1 over 3. But this must be equated to 33,5. Okay, I'll open my brackets, that is 12x. So 11 over 2 times 12x plus, when I simplify this, okay, when I simplify that, I'm not going to assume, let me just use my machine. Say 1 over 3 to the exponent of 10, close that bracket, then 1 minus 1 over 3. I'm getting 0,4999999. So if I round it off, I'll get a half. We got the 3,5. So when I simplify this 2 and that, so by 2 is 1, by 2 is 6. So 11 times 6, I'm going to get 66x plus a half is equal to 33,5. Then I can, let me just use this space here. I can move this half that side, so it means 66x is equal to 33,5 minus a half. We know that a half is 0,5. So 66x is the same as 33. I'll divide by 66 on either sides, so that my x becomes, is it a half also? Just confirm, yes. So x becomes a half. So that is question number 2. That's question number 2. Alright, then question number 3. Question number 3. Okay, they're telling us that in a quadratic sequence, these are the following properties. The second difference is a 10. Okay, the first 2 terms are equal. T1 is the same as T2. And then T1, T2, and T3 will give us 28. Show that the general term is that. So with such questions, guys, just come up with something. Okay. So I'm gonna let my first term and second term be maybe later. I can't use A, that's fine. Let me use X. It's fine. It will make much more sense. So if my first term is X, my second term is also X, and then maybe this is T3, which I can call, I don't know, call it a C. It's fine. So I'm letting T1 equal to T2 be equal to X. And I'm letting my T3 be X. It's fine. What I know is that this is going to represent the first difference, because x minus x will give us a 0, and then this is going to be like c minus x. Okay. And then they told us that the second difference is a 10. What does this mean? This means that if I get my c minus x minus a 0, I must get a 10. So c is the same as 10 plus 1 plus x. I've made c the subject to the formula. I can call this equation number 1. But we know that T1 plus T2 plus T3. So which means if I have my x plus the T3, which is my c now, it's gonna be 10 plus x must give us 8. I'm trying to get the value of x first and shall get the general term. So 1, 2, those are 3 x's is equal to, I can move the 10 that side, that's gonna give me 18. Divide both sides by 3, which means x is a 6. Okay. If x is a 6, which means my third term is gonna be 10 plus 6, which gives me 16. Alright. So I'll start. I will start and look at my second difference. So I know that 2a is the same as 10. Divide both sides by 2, which means my a is a 5. Okay, that's fine. And then I know that 3a plus a b must give us 0. But our a is 5, so that's going to be 3 times 5 plus b is 0. Move the 3 and 5 that side, that's a negative 15. Okay, which is that. And then a plus b plus c must give us this x, which x we found as a 6. Okay, so my a is a 5, my b is a negative 15, plus c is equal to 6. Okay, so 5 and 15, that's negative 10, plus c is equal to 6. Move the 10 that side, so it becomes negative 16. Okay, just for the sake of this last part, please remember the c I'm using here is not the same c in this part. This can even be a d, just for the confusion being rectified, so that we don't have the same kind of thing. We can use a d. Okay, so which means our Tn is going to be 5n squared. We have the minus 15n. Oops, why did I get a negative 16? Something is amiss here. Guys, if I move the 10 that side, it's a plus, so which means it's a positive 16. A positive 16. Okay, so that is that with that question 3.1. Then 3.2 is 216 a term in this sequence. So for us to justify this, we need to equate this whole expression 5n squared minus 15n plus 16. We equate it to 216 and find what position it represents. So I'm gonna move the 216 that side, so 5n squared minus 5n, that's going to be negative 200 is equal to 0. Then I can divide through by 5. Divide through by 5, that's going to be n squared minus 3n minus 40 is equal to 0. Then I can use my factors. I can use the quadratic formula. This is n, it's going to be 8, n and 5. So I make this a negative and a positive to give me this expression is equal to 0. So which means either n is 8 or n is negative 5. But remember, we're looking for the position, and we can never have a negative position. Therefore, 216 is the 8th term of that sequence. Alright. So they say, is this a term or not? The answer is yes. Yes, 2 and 6 is the 8th term of the sequence. Then question number 4. They're telling us that we've been given this function p into x is equal to 1 over 3 to the exponent of x. Okay. Is this an increasing or decreasing? So we need to know what type of graph, what type of function is this. This is an exponential function or graph. Condition is, if this is a b, one thing we know, if it is in the form of y is equal to b to the x. If b is greater than 1, then the function will be increasing. Okay. But if b is in between 0 and 1, then the function is decreasing. So in this case, since 1 over 3 is between 0 and 1, the function is decreasing. Do they want a reason? No. So that is enough. So the function is decreasing. And then 4.1.2, they want us to get the inverse. So it was p of x is equal to 1 over 3 to the exponent of x. So in most cases, whenever we ask for the inverse, this is going to be in the log form. So it can be log the same base, 1 over 3, put the x there, and make that a y. So y is equal to the log 1 over 3 to the x. Okay, so that is that. Alternatively, what people usually do is 1 over 3 to that, switch that x is the same as 1 over 3 to the exponent of y. Then introduce logs. So log x is equal to the log 1 over 3. This y is the second power. It will come that side. So that log x is equal to y log 1 over 3. Then when we divide both sides by log 1 over 3 and log 1 over 3, that cancels that. And then this will be the same as that. Okay. Then they want us to write down the domain of the inverse. So one thing we need to know is that the domain of the inverse will be the range of the original, since we are switching them around. So originally, our range was y must be greater than 0. Okay, that was the original range for the p of x. So when you are writing domain, since domain represents the x values, the input values, we're going to just say x must be greater than 0. Okay, so that is that. Then 4.1.4, write down the equation of the asymptote. So if I have my p of x, which is 1 over 3 to the x, and then we are subtracting 5, so we are shifting it 5 units down. This extra portion, remember y is equal to b of x plus q. This q represents the asymptote. So I'm just going to say y is equal to negative 5. That is my asymptote. Then we move on. Given the function 4 over x minus 1 plus 2, find the equations of the asymptotes. So this is a hyperbola, just from the nature of this, because we have a number and then the x is at the bottom. So with asymptotes, we have the horizontal, we brush with the horizontal, get the x minus 1, equate it to 0, which means x is a 1. And then for the y, or for the horizontal asymptote, because it's the vertical, y is going to be equal to still 2. So x is equal to 1 and y is equal to 2. So they want us to get the x-intercept. One thing we know is that for x-intercept, y must always be 0, which y is also the same as the f of x. Where there is f of x, we're going to put a 0 there. So 0 is equal to 4 over x minus 1 plus 2. I can move this to that side so that I have negative 2 and cross multiply same time. Okay, because I'm saying negative 2 is equal to 4 over x minus 1. And then I multiply both sides by this denominator or cross multiply. Open this up, negative 2x plus 2 is equal to 4. Move the 2 that side, negative 2x is equal to 2. Is that true? Yes. Divide both sides by negative 2, which means x is going to be negative 1. It's the x-intercept and not the coordinates. Okay, then they want us to sketch 3 marks, so it's 4 marks, guys. You cannot just throw this away. Now there are people who be like, when I see sketching, skip. Guys, these marks are for grabs. Then I can put my x somewhere there. So step number 1 when you are sketching a hyperbola is the asymptotes. Just draw the asymptotes. We said x is 1 and y is 2. So my x1 is going to be somewhere here. Oops, I'm sorry. Let me just put it somewhere here. The dotted line. Okay, I'll call that my 1. And then the other one is a y2. This is my 2. I'll just draw the asymptote somewhere here. Okay. Then we say that the intercepts. We had just one intercept and we said x is negative 1. Okay, x negative 1 could be somewhere here. And then we can still, because it's 4 over x minus 1 plus 2, we can still find the y-intercept where x is 0. So 4 into negative 1 plus 2. So 4 over negative 1 plus 2 is going to give me a negative 2. So close to the same distance, it's a negative 2. So the graph must pass there, graph must touch it. But now, since our a is positive, okay, we know that if a or this number on top is positive, the graph is just going to lie within quadrant number 1 and quadrant number 3. If this a was less than 0, then the graph would be quadrant 2 and quadrant number 4. Now when we talk of quadrants, we're not focusing on the original x and y. We're focusing on the asymptotes, the quadrants formed by the asymptotes. Okay? So my quadrant 1 is going to be here. And then my quadrant 3 is going to be this area here. So since there is nothing the graph to touch on in quadrant number 1, just draw your graph that tends towards the asymptotes. And put the arrows if you wish. And then just gonna move this a bit. Okay. So I can just stretch something that passes through these points and moves towards the asymptotes. And then I can just move this towards this as well. Okay, so that is my f. So in most cases, or in all cases, we need to have 2 arms of a hyperbola. Hyperbola must have 2 arms. Alright, then we move on. They want us to use the graph to determine the values of x for which 4 over x minus 1 is greater or equal to 2. So in this case, if I move this to this side, I'll get my original graph. So 4 over x minus 1 plus 2 is greater or equal to 0. So where do I find the function to be above the x-axis? That's what it means. Y is greater than 0. Okay? Because f of x is the same as y is the same as this function. Where do I find it above the x-axis? Okay. So from this point to the left, okay, to the left, the graph will be above. But also, when I look at from this point, from positive 1, moving to the positive infinity, from negative 1 to negative infinity, graph is above, and then from positive 1 to that side. So my representation is going to be x must be less or equal to negative 1. Okay? And also x must be greater than 1. So those are the two conditions under which the graph will be above the y-axis. So less or equal because the graph is passing through negative 1, and then we're using just greater because 1 is an asymptote. Can't pass there. Then 4.2.5, they want us to get the equation of the axis of symmetry of f of this. Okay, so our original, which is 4 for x minus 1 plus 2, is being shifted some units to the right. Okay, so where there is x, I can replace all of that. So 4 over x minus 2 minus 1 plus 2. So that's going to be 4 over x minus 3 plus 2. So this is the new function. Okay. So with this new function, I know that the asymptotes are going to be 3 and 2. Okay. X is going to be 3 and then y is going to be 2. So it's the same function or it's the same graph, but we're just shifting it 2 units to the right, so that this asymptote moves plus 2 to be somewhere there. Now, when you're finding the equation of your axis of symmetry, there are two. We have y is equal to x plus c, and then we have y is equal to negative x plus c. Now, for us to get the value of c, we normally use the intersection of the asymptotes. So since they want one with a negative gradient, then I'll go with this. So I'll say y is equal to negative x plus c. That is, y can put a 2 is equal to negative 3 plus c. Next to the subject, c becomes a 5. Then my equation becomes negative x plus a 5. That becomes the equation of the axis of symmetry. Alright, question number 5. Question number 5. They're telling us that the graphs of functions f of x, which is negative x plus 3 squared plus 4. And then g of x is x plus 5. Okay. Drawn below, we have A and B. That's where the graphs are intersecting, or that's the point where the graphs are equal. Then they want us to get the coordinates of the turning point. So when you look at the format that is being given, this is a turning point format for f to a parabola. So these 3 and the 4 will represent the coordinates of the turning point. But what we do, we only have to change the sign of the 3 for the x. So we can say that coordinates of the turning points are going to be negative 3 and positive 4. If this is kind of hard for you to notice, you can still open that up using your FOIA, so that it's x squared plus 6x plus a 9, then plus a 4. When you introduce the negative, it's going to be negative x squared minus 6x minus 9 plus 4. That's x squared negative minus 6x minus 5. And then you apply the whatever, the axis of symmetry. X is negative b over 2a. Okay, that's negative and negative 6 over 2. Your a is a negative 1. When you simplify this, it will give you the 3. The negative 3. And then if you get that negative 3 and put it into that, you're going to end up with just 4. Alright, so that's how one would go about it. But from the first point, given the fact that it's 2 marks, you just needed to spot that. Then they want us to get a range. Now range represents y values for which f is valid. Y values that cover the graph of the graph of f. So this is our f. And we can see that the highest point it can go is just a 4. And then below. All the values below 4 are valid for the graph, because the graph can extend into the negative infinities. So I'm just gonna say that y is less or equal to 4. Alternatively, someone can say negative y is less or equal to, what am I saying? Negative infinity is less or equal to y less or equal to 4. This is also acceptable. Then now 5.3, can we show that the coordinates of a and b are negative 5 and negative 4? Now since my equation is negative x plus 4 squared, it's a plus 3, sorry, and then plus 4. What is a and what is b? That is what I need to find out. So a is a point of intersection as much as it is an intercept, and then b is an intersection point for the two graphs. So we know that at a and b, the graphs are going to be equal. Okay. We say g of x is x plus 5. So we're saying that at a and b, f of x must be the same as the g of x. Point of intersection means the graphs are equal. So I'm going to solve this simultaneously. I'm going to equate everything. Okay, so I'm going to say negative x plus 3 squared plus 4 should be the same as x plus 5. Okay. Remember, we opened this up somewhere there. We had negative x squared. Someone remind me, minus 6x minus 5. Okay. That is minus 6x plus 5 is equal to x plus 5. Create a standard form. That's going to be negative x squared. This and that is going to be negative 7x plus 0 is equal to 0. And then I can write through by the negative. Just a moment. What's going on here? Was that a plus 5 or a minus 5? Wait a moment. It was minus 5. My bad. Just listening. Okay, so this is a negative 5. Okay, we said minus 5. So this not 0. This 0 disappear. Okay. So when I move the 5 aside, it will be minus 10. Divide through by negative. That's going to be x squared plus 7x plus 10 is 0. The two numbers that I multiply to give me a 10, I add them to get a 5. Sorry, 7 is x plus 5 and then x plus 2. Then this bracket will give me x as a 5 or x as a negative 2. Then we can see, what am I doing here? Negative 5. What's going on? x is -5 and x is -2. So, which means since my a is the farthest, it will have the smaller value. So the a of x is -5, and then the bx is going to be -2. Guys, that's what we do. They want the x coordinates only. Then they're telling us hence, which means from where we stopped, they want us to get the values of c, for which the equation of -x plus c plus 3 squared plus a 4 is x plus c plus 5. This x plus c is like we are shifting the graph some units within the horizontal axis so that the graph can have one negative and then one positive root. So from the position of the graph, for this to have one negative root and one positive root, it's like this graph must be shifted some units. So if this is a -2, that's our negative is like must be shifted these units. These are 2 units, just slightly 2 units to the right. Okay. So it makes sense. So reflection is not gonna make sense. So I'm gonna take c to be slightly greater than 2. And if I plus that, which means 2 is going to give me -3. Okay, that's going to be 5. Which can't happen. That's a 1, which means it can move just 4 units. Oh, nice. Okay, I'm just gonna say c must be greater than, must be between 2 and 4. Just say 2 is less c and less 4, because I can only shift it 4 units. Then it will make sense for it to have one positive and one negative. Then 1.5, they're telling us the maximum distance between f and g. This interval is k. And then if h of x is the same as h of x plus k, determine the equation of h. So we need to find what k is, that maximum distance between the intervals of x and x. So for us to get the maximum distance, we need to determine the difference between the 2 graphs. Okay. And from the look of things, I see the f being on top. So I'm just gonna say f minus g of x. So remember that was x squared minus 6x minus 5, and then I'm subtracting x plus 5. So that's -x squared minus 7x, you said minus 10. Okay, which you already had. Then we need to find the maximum. So for maximum distance, I can find the first derivative, or I can even use the axis of symmetry. Okay. So for maximum, I don't know, whichever one is simpler. Okay, so if I use the first derivative, it's going to be -2x minus 7, and then I'll equate it to 0, and then I'll solve for x. So my x is going to be 7 over negative 2. If I use the axis of symmetry of negative b over 2a, so my b is negative 7 over 2 times my h is negative 1, which is still negative 7 over 2. So either way. So if this is the point where I'm having my maximum distance, I'll substitute this into the original to get what my k is. Okay. So then that's going to be negative, we have negative 7 over 2 squared minus 7 into negative 7 over 2 minus 10. Okay, let me just confirm. That is that minus 7 into P.1 minus 10. I'm having 2.25 in the positive. Then, which means my h of x is going to be the g of x, which is x plus 5, and then plus this 2.25 is representing the k, 2.25. So that is going to be 7.25. That is the h of x. Alright, so that's how I would have gone about that. It's either first derivative here or axis of symmetry to get the maximum point. Alright, then that's 5. I go to question number 6. Number 6 is telling me that a company bought a photocopier for 150,000 rands on the 1st of July 2022. They will use the old photocopy as a trading when they replace with a similar on the 30th of June 2027. Then the average rate of inflation is 6.5 for the next 5 years, turning the price of a similar photocopy in that time. So whenever we talk about inflation, that is compound interest. So a is p into 1 plus I to the exponent of n. Then we do the substitution. That is 150,000 into 1 plus. That's going to be 6.5, or someone can just divide that by 100 straight away. They have 0.065 to the exponent of 5. Okay, just punch this into your machine. Your machine 150 tau into 1 plus 0.065. Oops, to the exponent of 5. And I'm having 20,551.2,999, which I'm going to round up to just 1/3. Okay, so that is how much the machine will cost in 5 years' time. 205,539. Then calculate the trading value for the old photocopier. After 5 years, it depreciates at 9% straight line. So the keyword is straight line. So this time around, they are not using reducing balance. So with a straight line, it's just going to be 1 minus 1. 1 minus 9. That is straight line method, depreciation. So our P, we're looking for A. Our P is the 150. We know that our N is going to be 5 and the I is 9%. So substitute that 150 tau into 1 minus 90.09 multiplied by 5. Put this in your machine. My machine into 1 minus 0.09 times 5. I'm getting 82,500. 82,500. Okay, so that is what the machine gonna be worth after 5 years. Then 6.3, the company sets up a sinking fund to cover the replacement costs of the benefit copy. The fund earns interest at this much and then on the monthly. Okay, the company made the first deposit on the 31st of July. Just something that I need to know. They bought the machine on the 1st of July. Okay. And then on the 31st of July, they made payment. Okay. And then we'll continue to do so until 31 May. Alright. Which is 1 month prior to the new copy being bought. How much should be deposited at the end of each month so that the company will be able to buy the new photocopy? So a sinking fund is basically a fund that is set aside, or it's more like an investment that is put aside to cater for replacements, especially for machines and vehicles and stuff like that. So what normally happens, like if the current machine or the current truck that is being used is sold off in a certain period of time, whatever they get out of that truck may not be enough to buy anymore. So whatever will be saved over the period is what we call the sinking fund. And that money will be under the present. Is a present? No, it will be a future value. Okay. So what I need to know is what is my future value? How much am I looking at? So since we had 205513, okay, then we subtract. This is going to be the cost of the new machine. And then subtract what the old one is worth, which is 82,500. Okay, 205513 minus 82,500. This giving me 123,013. So this is how much must be put aside or must be saved so that they can be able to buy the new machine. Then the question is asking for the monthly installment. Is it true? Yes. How much should be deposited at the end of each month? So I don't have X. Maybe before I even talk about X, which formula am I using? I'm saying F is equal to X into 1 plus I to the exponent of n minus 1 over I. Okay, so we're looking for X. We have our F, which is this much. And then the interest rate, they told us it is 7, something something. They say 7,85 compounded monthly. Multiply that by 12, it's fine. And then my N. Okay. So since the first deposit was made on the 31st of July 2022, okay, 2023, 2024, 2025, it's going to be 2026 and 2027. Okay, so 1st July. So 1st July here also. 1st July. 1st July. This is 1st July. Okay, and also 1st July. Okay, so this is going to be 1, 2, 3, and then 4, It's meant to be 5 years. Okay, but the payment is not getting to the 1st of July. It's stopping in May, 31st May. Which means since these people paid an early payoff and there are 2 months that are left before the final payment, which means I'm going to take off one payment to cater for the early payment, then I'm going to be left with less than 60 months, because we know 5 times 12 is meant to be 60 months. Then I subtract my one, which is going to give me 59 months. Okay, so my N, I'm taking it as a 59. So since I'm looking for X, I'm going to make X the subject first. So I'll cross multiply. So I'll have my future value times I is equal to X into this whole thing. And then I'll divide both sides by that bracket. So the future value times the interest rate over 1 plus I to the exponent of n minus 1. Then I'll do my substitution. That's 1, 2, 3, 0, 1, 3 times my interest rate, say it's 7.8%, 7.89. That's going to be 0.0789. Is it 89 or 85? Man, what's the problem? It's 85. Let me confirm, please. Okay, it's 85 guys. Okay. We're dividing this by 12 since we're compounding it monthly. That is fine. Over, we have 1 plus 0.0785 over 12. We can alternatively use that button of the percentage in the calculator so that you don't have to divide by 100. Okay, so when I punch this into my machine, 013 times what are you getting? So this is 1 plus 0.0785 over 12. I'll close this bracket to the exponent of 59, and then I'll subtract my 1. Oops, I'm getting 1,715 rands, 16 cents. So this is how much they're gonna be paying every month for 59 months so that they can cover the new machine. Okay, 6.2. 6.2. They're telling us that today Andrew borrowed 200,000 from a bank. The bank charges interest that pays per annum compounded 4 times. Andrew is going to make payments of 6,000. So X is 6,000. Interest rate, we say 5.25% over 4. 6,000 at the end of every 3 months. So when they talk of every 3 months, that's a quarter. So first payment will be made in 3 months from now, which is the correct timing. How long in years will Andrew take to settle the loan? So they want the end. Now, since this is a loan, so it's going to be representing our present value, which is 200,000 rands. So from the present value from loan, which is H into 1 minus 1 plus I to the negative n, divide this by I. Okay. So I'm just going to say 200,000 is equal to the payment, which is 6,000 into 1 minus 1 plus the I. I'll go the old school way, 5,25. I'm dividing it by 100, which is 0,0525. I'm dividing it by 4 since the compounding is quarterly. Then my exponent here, I'm going to say 4n. 4 is for the quarter, and n will represent the number of years. But that must be negative. I'm dividing this by the same interest rate, 0,0525, divide by 4. Okay, so step number 1, I'm going to simplify this and that. If I can divide them, or I can multiply this and that, and then divide by 6,000. Whichever way. Divide this and then multiply, or simplify this and divide it outside. When I do that, I'm going to say 200,000, I'm dividing it by 6,000. Okay, then I'm multiplying it by 0,0525 over 4. So I'm getting 7 over 16 is equal to, I'm saying 1 minus, when I simplify what is inside here, I'm going to have 1 plus 0,0525 over 4 is giving me something like 1621 over 1.6 to the exponent of negative 4n. Okay. Then I can move the one that side. So 7 over 16, I'm subtracting the 1. So I need to move this one that side. That's going to give me negative 9 over 16. And we got to the negative 1621 over 1.6 to the exponent of negative 4n. And then since either sides are having the negative, they will cancel out to be a positive. Then I can introduce my logs here. So I'll say negative 4n must be the log. Since this is a base, it must also be maintained as a base here. Okay, and then this is going to be 9 over 16 as an exponent. Okay, so when I simplify this, do I have space? Do I have space? I need to create space. Okay, so I'm just going to get it a bit down. I'll take it out. So negative 4n is equal to, that is our log. The bottom have 1621 over 1.6. That's going to be 9 over, guys, this is a 16 multiplier. Okay, 9 over 16. I'm getting negative 44, 124. Yeah. Then I can divide both sides by negative 4. And then my n becomes 11,03. So this guy is going to take approximately 11 years. Okay. Just to clear off that one. Okay, that would be my approach to that question. Then 7.1 calculus. Determine the first derivative from first principles. So whenever they talk of first principles, then we know that the limit as h tends to 0 of f of x plus h minus f of x over h. So this is the formula we normally use. So what I know is that this is my f of x. I need to find what is my f of x plus h. So where there is x, I'm going to replace with x plus h. So negative 2 into x plus h squared minus 1. I can open this, so I can just put it where it is. Okay, limit as h tends to 0. I'm gonna say negative 2 into x plus h squared minus 1, then minus the whole of f, which is negative 2x squared minus 1 over h. Then we're seeing the limit as h tends to 0. I'll open this up. I have negative 2 FOIL that, x squared plus 2xh plus h squared minus 1. Open that, so 2x squared plus 1. Everything is over h. Now move to the side, so still the limit as h tends to 0. I'll open this bracket of mine, negative 2x squared minus 4xh minus 2h squared. And then I'm having a minus 1 plus 2x squared plus 1. Everything is over h. Remember, whenever you do first principles, certain things must cancel. So this is going to cancel with that. They are the same, but the signs are opposite. This is going to cancel that. Then I'm left with negative 4xh minus 2x squared. I can factorize out the h. Okay, so that I have negative 4x minus 2h over h. So this cancels that. And then if I replace my h with a 0, then I'm going to be left with just negative 4x. So that's how we'll get the 5 marks from first principles. Remember the x plus h. This is important. And how you open it up together with that negative 2. Then 7.2.1, they want us to find the first derivative if it's given like this. So use your rules. Remember, if we have a to the n, we'll say the n must multiply with the coefficient and then we subtract by 1. That's the rule that we're using for us to find y, maybe the n. Okay, so that's going to be negative 2 times 3. That's going to be negative 6x. Then we subtract 1, that is squared. Then 3 times 2 is going to be 6x. 2 minus 1, just that. Then that is our answer for that. Then 7.2.2. So whenever we have square roots, try to eliminate those roots and rather you write it in the form of exponents. So this would be the same as 2x plus 1 over, I know that the square root of 4 is 2. And in this x, I'm going to write it as exponent a half. Okay, it would be the same as 1 over 2 root x. Then I can move this to the top, which is going to be 2x plus 1 over 2x to the exponent of a half. And then I need to find my divide x from this. Okay, divide x there. It's going to be, that's a 2, because 1 times 2 is 2, then subtract 10. This is a negative, remember, since the exponent is gone up. A negative a half times a half is going to give me negative 1 over 4. X subtract 1 from there, I'm going to have negative 3 over 2. So my answer, I can express it as 2 minus x 3 over 2 negative over 4. That will be my answer. For as long as the question does not tell you to leave your answer with a positive exponent, just leave it like this and move, please. Alright, then 7.3. They are telling us that the graph y is equal to first derivative has a minimum. Turning point at this. Determine the values of x for which this is concave. So concavity in most cases depends on the turning points. Okay, the point where we find inflection is usually the average turning points. So since our x is a 1 and we're talking about concave down, remember whenever we find concave down or concavity downwards, we find the first derivative being less than 0. And in this case, since it is a graph in that sort of manner, the graph will only be concave down between x being 1 on the left hand side. So here I'm just going to say x must be less than 1. And then those are the values x for which it's going to be concave down. Then 8.3, so 8.1. If you're given this function, it's a cubic function, write down the y-intercept. So y-intercept is usually the number without a variable. Okay, you can say it's negative 10. Alternatively, we know that the y-intercept, x is a 0. You can substitute with a 0. You're still going to get negative 10. Then show that 2 is a root of the equation. So for a number to be a root, if we substitute that number into the function, we must end up with a 0. And if that is true, then that number is a root. So let's do it here. So that is 2 cubed plus 4 times 2 squared minus 7 times 2 minus 10. So that's going to be 8 plus 16 minus 14 minus 10. That's a 24 minus a 24, which is a 0. Therefore, f of 2 is giving us a 0. Hence, 2 is a root. 2 is a root. Okay. And then hence factorize. Okay. So if 2 is one of the roots, for us to find the other roots, you can use your vector formula. If that is our vector, then use your long division. Alternatively, we can use what we call the synthetic approach. Let me see, this is A, B, C, and D. I prefer the synthetic because the chances of me going wrong are very, very slim. Okay, let me just take this out. Okay, I'm saying A, B, C, and D. So A, B, C, and D represent the coefficients of my function. Okay. So with my A, they told me it's a 1. My B is a 4. My C is negative 7. And my D is a 10. Okay. Now since the first root is a 2, I'll put a 2 there. And then I'll just shade this off. In this one, I'll just write it down. Then what is 1 times 2? It's a 2. I plus this. I get a 6. Okay. And then 6 times 2, I'm getting 12. When I plus this, I get a 5. And 5 times 2. Did I do something wrong? What is the D, guys? Say negative 10, not positive. What's the problem? Okay, this and that is 10. Then I plus that, I must always get a 0 at the end. So which means I can draw my diagonal lines to say that B is A, this is the C, and then that is the D. So which means it's going to be x squared. Remember, these are coefficients. Plus 6x plus a 5. I can equate this to 0, or I don't even need to equate it to 0. I need to factorize that. The two brackets, choose x and x. Which numbers do I multiply to give me 5? I add to get 6. It has to be 5 and 1. And then I plus that. Okay. So which means for me to factorize f completely, this first root can give me this vector of x minus 2. Okay. because x equals 2, move this that side, you get x minus 2. And then I can combine it with this, that is x plus 5. So I'll factorize that completely. Then if it's further given that the coordinates of the turning points are approximately this much, they want us to draw a sketch. Now with the sketch, we have the x-intercepts. Remember, roots are more like the x-intercepts. Then we have the y-intercept, which was the negative 10. Look at your a. Our a is greater than 0, which means this graph must frown and then smile, something like that. If it's less than 0, then it will be the other way around. So not gonna waste a lot of time. If that is my x, and probably that is my y. Okay, then I'm gonna color. Let me use that. No, that is too faint for my liking. Use green. So let's mark off the intercepts. This is a 2, negative 1, negative 5. So if this is my 2, this can be my negative 1, probably negative 5. Turning point, we said 0, 7 and negative. Okay, negative something. No, 0, 7 and just a negative 12. Somewhere there. Okay. And then this is negative 3,4. Okay, somewhere halfway. And then top there, if I call that my 20. I hope it comes out okay. Then my intercept is negative 10. If I put it somewhere there, then I can connect. So I know that that is my maximum, and then this is my turning point. And then I can just use dotted lines first, so that I see what kind of shape I have. If I'm happy with it, then I'll go on and draw the outline. Okay. Then just make this bold. Okay. So I'm gonna have something like that. Okay, so we're only gonna mark the intercepts and then the shape in most cases. Okay, so that becomes the graph. What I don't know. This one must come back. So negative 1 and 2 and so guys, that is just a sketch of how the graph will look like. And then they want us to use the graph to determine the values of x for which the first derivative is less than 0. So first derivative is normally the gradient function. Okay, so where do we find the gradient to be less than 0? In other words, the gradient must be decreasing. Okay, so if this is 0,7, this is negative 3,4. So between this area, that's where we see the graph to be decreasing, because before that the graph is in increasing format, and then after the 0,7 the graph is increasing. So we're gonna say negative 3,4 is less x, and then is less 0,7. So between those intervals, the graph will be seen to be decreasing. Then the next question, that is 8.5.2. They're telling us the gradient, the x values with the gradient of the tangent will be minimum. So for any tangent to have a minimum gradient, it must occur at the point of inflection. Okay. And how do we get the point of inflection? Say f double prime. So since we had x squared, Was it plus 4x minus 7x minus 10? Just confirm that. Okay, that is true. So my first derivative, let me find the first derivative first. That's gonna be 2x plus 4 minus 7. And then my second derivative is going to be this. I'm sorry guys, I'll take this back. The function is x cubed. This is x squared. So first derivative is going to be 3x squared plus 8x minus 7. So second derivative is going to be 6x plus 8. When I equate this to 0 and move the 8 outside, x must be negative 8 over 6, which is negative 4 over 3. So at this point where x is negative 4 over 3, that's where the tangent will have minimum gradient. Then 8.5.3, the first derivative and second derivative being less or equal to 0. Okay, so we know that the first derivative is going to be a parabola. If I call that my x, then I draw my parabola nicely. Okay, this is going to represent the first derivative. And these points will represent the turning points, which is negative 3,4, and then that's going to be the 0,7. We know the second derivative is going to be a straight line. Let me just draw something like that. That is my y. Straight line, we said x is negative 3 over 4 and y is 0. And then that is 8. So that is 8. That line is to be drawn to be moving somewhere. So 4 over 3 negative. So what this means is that for two functions multiplied to be less or equal to 0, it's like one of them must be positive and the other has to be negative, or negative and positive. So we need to look at those conditions before we can come up with the solutions. Okay, so when I look at this point, let me cut this out. Remember, we're looking for values of x. So at this point of 3 over 4, this graph is positive, and then this graph is negative. Okay, so from 3,4 to the left. So you can say x is less or equal to negative 3,4. That is one. And then when I look at this point, I can see that this graph is in the positive, but then this f first derivative is on the negative. But this only occurs up to this point of 0,7, okay, where this one is on top and this one is below. So I'm gonna say negative 4 over 3 must be less or equal to x, and then less or equal to 0,7. So those are the intervals that they were looking for. Then question number 9. A wire which is 12 meters long is cut into 2 pieces. Okay. One part is bent to form an equilateral triangle, and the other is bent to form a square. A side of the triangle has length of 2x. Okay, so which means that is equilateral. One thing about equilateral triangle is that all sides are equal. So that is 2x, 2x, and 2x. Which means the total perimeter of the triangle is 6x. Total sides, the triangle is 6x. Then write down the length of the side of the square. And the other thing we know about the square is that all the sides are also equal, but they are 4. So if this is 6x, what is left of the wire? It's going to be 12 meters minus the 6x. So this is the total perimeter of the square. Then for us to get one side of the square, we just get 12 minus 6x, and then I'll divide this by 4. Okay, when I split that, it's like 12 divided by 4 is going to be 3, minus 6 divided by 4 is going to be 3 over 2x. I don't know, I can call this meters. It's fine. So that is the length of one side, 3 minus 3 over 2. So 12 minus 6x over 4. When you simplify, someone can even factorize that. Maximum is a 3, is it not? It's a 2. Is that so? It's a 3. It's 3. And then you have 4 minus 2x, and then by 4. Okay, so that is that. Let's not debate over the factorization. Then we move on. Then they're telling us that if this square is now used, now we use focusing on the square whose side is 3 minus 3 over 2. Okay. So if we choose to use the square as the base of the times of prism and the height is from determining the maximum volume. So one thing we know about volume is that we must get the area of the base, and then we multiply that area by the height. So since the area, or since the base is a square, which means the area is going to be 3 minus 3 over 2x multiplied by 3 minus 3 over 2x. Then I'll multiply by my OX. Okay. I'll open this up using the foil. That's going to be 9 minus 9 over 2x, and then minus 9 over 2x. That is going to be 9 over 4x squared. I'm multiplying this by 4x. When I collect my terms in the middle there, it's going to be 9 minus 9x plus 9 over 4x squared being multiplied by 4x. Then I can open up with the 4x. That's going to be 36x minus 36x squared plus 9x cubed. So that's the volume, which I can rewrite as this plus 36x. Okay, this is the volume formula. Then the question is asking for the maximum volume. So for maximum volume, okay, we need to derive. We must find dv, dx, and equal to 0. Okay, so my first derivative is going to be 27x squared minus 72x plus 36 is equal to 0. Okay, then from there I can divide through by 9. Yeah, so that's going to be 3x squared minus 8x plus 4 is equal to 0. Then I can use my quadratic formula. I can open up using the brackets. And to get 4, I can use 2 and 2. Let's see, that is 6 plus 2 is 8. I'll make this a minus so that my product is positive. So which means from this 3x minus 2 is equal to 0, or x minus 2 is equal to 0. So x here is going to be 2 over 3. Then x here is going to be 2. So for me to get the maximum volume, It's either x has to be 2 or x has to be 2 over 3. The question wants the volume. Okay, determine the maximum volume. Okay. So I can get these numbers and just substitute them into the volume formula. So if I use V of 2, that's 9 times 2 cubed minus 36 times 2 squared plus 36 times 2. Okay, I'm getting a 0. And then if I use 2 over 3, okay, that's gonna be 9 into 2 over 3 cubed minus 36 into 2 over 3 squared plus 36 into 2 over 3. And substitute that. Okay, so that's 2 over 3 cubed minus 36 times 2 over 3. That is squared plus 36 into 2 over 3. I'm getting 32 over 3, which is the same as 10,67 meters cubed. So this will be the maximum volume, because 0 can be maximum number is 10. Okay, so that is question number 9. Then lastly, question number 10. They're telling us that a group of people participated in a trial to test a headache pill. 50% of the participants received the headache pill, and then 50% of the participants received the sugar pill. Okay? 2 over 5 of the group receiving the headache were not cured, and then 3 over 10 receiving the sugar were cured. They want us to draw a tree diagram. Okay, so with the tree diagram, I'm going to start with either people getting the headache or the sugar pill. Okay, so I'm going to use the headache or the sugar. It's 50%, which is the same as a half. Just write it, I can leave it as a half of 50% or even a decimal 0.5. Okay, if you receive the headache pill, it's either you're cured or you're not cured. And then if you receive the sugar, it's either you're cured or you're not cured. So 2 over 5 of the group receiving the headache is not cured. So that's 2 over 5. So what will be left here must be 3 over 5, because for every branch you must add up to 1. Just like a half and a half gave us a 1. So even this. Then 3 over 10 of the people that received the sugar were cured. So this is 3 over 10. Then this must be 7 over 10. So the outcomes will be headache pill and cured, headache pill not cured, sugar and cured, sugar and not cured. So these are our outcomes. Alright, we'll move on. .1.2, they're telling us that the probability that a person chosen at random from the group will not be cured. So there are two possibilities. It's either you will not be cured because you received the headache pill, or you will not be cured because you received the sugar pill. So I'm just going to say HN plus the probability, and then probability of this n. Okay, so for HN, I'll say a half times minus cured is 2 over 5. Then plus sugar not cured is a half times 7 over 10. Okay, I simplify that. That's gonna be like 1 over 5 plus 7 over 20. Just put this in your machine. 1 over 5 plus 7 over 20. That's 11 over 20. Or 0.55. Then 10.2. They are telling us that we have 3 events. Okay? We have A, B, and C. Probability of A is 2 over 5, probability of B is 1 over 4, probability of A or B is 13 over 20. Are the events A and B mutually exclusive? So, mutually exclusive events are basically events that cannot happen at the same time. In other words, they do not influence each other. In other words, there is no common ground between the events. And from the probability theorem and using the addition rule, we know that the probability of A and B must be 0 since the events cannot happen. So from that formula of A or B, the sum of probabilities, saying probability of A plus probability of B minus the probability of A and B. So for us to assume, or for us to come to a conclusion that they are either mutually or not mutually, we need to solve for probability of B. So probability of A or B told us that is 3 over 20. Probability of A is 2 over 5 plus probability of B is 1 over 4 minus A and B. Okay. So when I simplify 2 over 5 plus 1 over 4, that's giving me 13 over 20. So 13 over 20 is equal to 13 over 20 minus probability of A and B. So if I transpose this, move it that side, and this move it that side, which means the probability of A and B is going to be a 0. Okay? And we said for as long as it is a 0, then they are mutually exclusive. So the answer is yes. A and B are mutually exclusive. Mutually exclusive. The reason? Say probability of A and B is 0. Okay. Then 10.2.2, they want us to determine the probability of C only. If it's further given, the probability of A or C is that, and all of that. So if I assume to be having a Venn diagram, okay, this is, let me call this A. Remember, B and A are not meeting, so I'll just leave it there. And I'm having C that is meeting all of them. Since we have A and C, then we also have B and C. Okay, so remember, they told us that the probability of A was 2 over 5. So all of this is 2 over 5. Then the probability of B is 1 over 4. And then you just need to see. So if our sample space is a 1, okay, sample space is a 1, then you just fill in this. Okay. A and C must be 2 over 5. So if this is 2 over 5, okay, but probability of A and C is twice the probability of B and C. What does this mean? If I have B and C to be X, A and C must be twice. Okay. Then I can just apply my logic and represent that. So remember, A and C is 2 over 5. Must be twice the B and C, which is my X. So which means that this, I divide both sides by 2, which means my X is 1 over 5. Okay? So there is a 1 over 5 there. Then this will remain as 2 over 5, which is fine. Is there anything else we need? They want to see only this part. Okay, so for me to get my C only, I'll need to first of all get what C is. And since I have the probability of A or C, it's going to help me. I have the probability of A, I have the probability of that. Okay. So it will be probability of A plus the probability of C minus the probability of A and C. So A, we had it as 2 over 5. A or C is 7 over 10. C, I don't know. I'm subtracting the intersection, which is 2. A and C is also 2 over 5. Okay. Which means probability of C is just 7 over 10, because this is going to cancel that. Then if C is 7 over 10, the question is asking for the probability of C only. So C only is going to be my 7 over 10. Okay. I must subtract this area and subtract that area. Minus 2 over 5 and then minus 1 over 5. Then just see 2 over 5 minus 1 over 5. Okay, so which means it's 1 over 10. Okay, C only, because C only is just this area without the B and then without the A as well. Alright, so that is done. Then determine the probability that events A, B, and C do not take place. So what is within that? So this is 7 over 10. Let's put that. So we want the probability that is outside. Okay. So since I have the whole of P, so the 1 over 4. And we know that this 2 over 5 is the same as this 2 over 5, so that is a 0. I'm going to get 1, which is my total probability. I'm going to subtract the whole of 1 over 4. Okay. I'm also going to subtract the 2 over 5 for this part. And then I'll also subtract 1 over 10 for the C only. Okay. So I have 1 minus, we said 1 over 4. And then subtracting 2 over 5. And then subtracting 1 over 10. Something's not adding up. Something's not adding up. What did I do wrong? Okay. What did I do wrong? I was getting something out of range. I need to revisit this. Okay. A, B, or C. do not take place. Okay, this is 1 over 5. So I'm taking the whole of 1 over 4 out, so I don't need to find that. In my double counting, okay, then what if I take 1 minus 7 over 10? No, it's my mistake. It's my mistake. Sorry, I must have added, should have added. Okay, 1 minus, we've said 2 over 5 plus the 1 over 10 plus the 1 over 4. This is 2 over 5 plus 1 over 10 and then plus 1 over 4. I'm getting a quarter. Yes, makes sense. Okay, so that is that, guys. I'm sorry, it was meant to be addition and subtraction because there are brackets already, so there's no need of subtracting inside the brackets. Then 10.3, there are 7 friends, 4 boys and 3 girls that want to stand in a straight line next to each other for a selfie or a photo. In how many ways can the 3 girls stand next to each other? So if I have 7 spots, 2, 3, 4, 5, 6, and 7. If I'm talking of 3 girls standing next to each other, so it's like the 3 must move as a block. So how many options do we have? So we shall have this one being the first option, the second, the third, the fourth, and the fifth. So we have 5 options of moving this block. So if the first one is here, the first one can also be there, the first one can be there, the first one. So it's 5 different options. Times within the girls, you can always switch positions as well. Okay. So 3 factorial times 5 factorial. 3 factorial times 5 factorial, I'm getting 720 ways. Okay, and then 10.3.2, they're telling us that in the next photo, we want us to determine the probability that this boy and this girl will not stand next to each other. So before we determine this, we need to first of all find out how many possible ways are there, regardless of the conditions of who wants to stand next to each other and who doesn't stand each other. So if we have 7 factorial, this will be the total number of ways. The total ways is going to be 7 factorial. Okay. Then for us to find the number of ways of these people standing to each other or standing next to each other, we need to look at what are the chances of them being together, and then we can subtract from the total number of ways. So if I were to take both of them to be together, which means I'm having a block of 2, how many ways can they move? 1, 2, 3, 4, 5, and 6 ways. Okay, so that's going to be 6 factorial. And the 2 could switch positions. Okay, 6 factorial times 2 factorial. That is the number of ways for them to be together. Okay, so for them not to stand next to each other, it's going to be 7 factorial minus 6 factorial times 2 factorial. Okay. When I subtract that, let me say 7 factorial minus 6 factorial times 2 factorial. That's giving me 3.6 ways of them not standing next to each other. But the question is asking for the probability. So probability of not stand next to each other is going to be the number of ways, which is 3.6 divided by the 7 factorial. Okay, so if I divide this by my 7 factorial, I'll get 5 over 7, which is the same as 0.71 as well. Okay, so that is the probability that this boy and the girl will not stand next to each other. Alright guys, that is the end of the paper. Please, if there are any errors, any mistakes, please you can just correct us under the comments section. Okay, we're humans, but I tried my best, guys. So just go over that. Yeah, thank you very much. Let's meet in the next paper.